What is the area of this shape? So here we have a shape which is a compound shape, but this can be split up into more basic shapes. So if we draw a line across here, what we can do to find the area, so to find the space that the shape takes up altogether, to find the area, we can find the area of this rectangle, then find the area of the larger rectangle, and then add up our areas. So to find the area of a rectangle, we multiply the length by the width. But here we don't know what the width of this line here is. We can work it out because we know that this line is 10 and this line is 7. So we have 7 plus whatever this length here is equals 10. And 7 plus 3 is 10, so this length must be 3 centimetres. If we have 3 here and 7 here, that's 10 altogether. Now 4 times 3 is 12, so the area of this little rectangle is 12 centimetres squared. And to work out the area of the larger rectangle, we can see that the length is 10 and the width is 7, and 10 times 7 is 70. So the area of this larger rectangle is 70. But we want the area of the whole shape. So we can add the area of the larger rectangle and the area of the smaller rectangle, and 70 plus 12 is 82. So our area is 82 centimetres squared. There is another way of splitting up the shape. So we could draw a line down here, and then we have this longer rectangle and this rectangle here. So we can work out the area of each and then add them up like we did before. So for this rectangle here, we have a length of 10 and a width of 4, and 10 times 4 is 40. So the area of this rectangle is 40 centimetres squared. But now for this rectangle, we know that one of the side lengths is 7 centimetres, but we don't know the other one. We can work it out because we know that this length here is 10 centimetres and this length up here is 4 centimetres. So we have 4 plus something is 10. That means we have 6 centimetres here because 4 plus 6 is 10. So to find the area of a rectangle, we multiply the side lengths, and 7 times 6 is 42. So the area of this rectangle here is 42 centimetres. But we want the area of the whole shape. So we can add 40 and 42, and again that gives us an area of 82 centimetres squared. 1 and 48 is a factor pair of 48. Find 3 other factor pairs of 48. So remember, a factor of a number means that we can divide without getting a remainder. And we can think of factors in pairs. 1 and 48 are factors of 48 because 1 times 48 is 48. So we need to think what times what is also equal to 48. Well, if we divide 48 by 2, we get 24. So that means 2 times 24 is 48. So 2 and 24 make a factor pair for the number 48. If we divide by 3, we get 16. So 3 and 16 are factors as well, because 3 times 16 is 48. We could also have 4 and 12, because 4 times 12 is 48. Or we could have 6 times 8, because 6 times 8 is 48. So we have 4 possible answers for this question. As well as 1 and 48, we can make 4 other factor pairs for that number. Write each word in the correct box. So we have faces, edges and vertices, and we need to show how many of each a cube has. So remember, a cube is like a 3D square. Now the faces are the flat bits, and we have 3 faces that we can see, but we'll also have another face underneath and 2 more faces round the back. So a cube has 6 faces. Now the vertices are the corners or the pointy bits. We have 4 vertices at the top, but we also have 4 vertices at the bottom of our cube, so that's 8 vertices altogether. And then the edges are like the lines joining the faces. So we have 4 edges at the top, we have 4 edges at the bottom, and we also have 4 edges in the middle. So one of our edges will be round the back. So 4 at the top, 4 round the middle, and 4 edges along the bottom means that we have 12 edges altogether. Here is part of a shape on a square grid. Draw 2 more lines to make a shape which has a line of symmetry. So if a shape has a line of symmetry, we'll have the same reflected on both sides. So let's see if we can make a shape with a horizontal line of symmetry. So see if the same can be reflected on both sides of the line. To do that, we can look at our corners. So for this corner here, we go 2 squares down from the line, but if we go 2 squares up from the line, we get to this point here. And this point isn't on the line, isn't one of the corners, so we can't have a horizontal line of symmetry. Let's see if we can make a shape with a vertical line of symmetry. So this point here, we go 3 squares to the left of the line. So if we go 3 squares to the right, we can have a corner here. And then we can just draw 2 lines to join up our points, and we have a shape which has a line of symmetry because we have the same on both sides. This corner here is 1 to the left, and this corner 1 to the right. This corner here is 3 to the left, and this corner here 3 to the right. And then this corner is on our line of symmetry. This fence has 3 posts, equally spaced. Each post is 15 centimetres wide. The length of the fence is 153 centimetres. Calculate the length of one gap between 2 posts. So we have 3 posts, and those 3 posts all take up 15 centimetres. 15 times 3, or 15 plus 15 plus 15, is 45. So the length of the posts are 45 centimetres altogether. So 45 centimetres plus the 2 gaps equals 153 centimetres. So if we subtract the 45, so subtract what the posts take up, that gives us 108. So the 2 gaps together total 108 centimetres. We know that they're equally spaced. So to find the length of one gap, we can divide 108 by 2. Because if 108 is the length of 2 gaps, to find the length of one gap, we need to find half of 108. And we might need to use short division for this, but we'll get 54 centimetres as the length of one gap. And then we can check 15 plus 54 plus 15 plus 54 plus 15 should total 153. Here is a sorting diagram with 4 sections, A, B, C and D. Write a number that could go in section C. So if we find section C, we can see that this number needs to be a multiple of 10, but not a multiple of 20. Remember, a multiple of a number is in that number's times table. So multiples of 10 are numbers like 10, 20, 30, 40, and so on, and multiples of 20 will be 20, 40, 60, 80, and so on. So the numbers 10, 30, 50, 70, many more possibilities could go in section C. because these numbers are multiples of 10. They're in the 10 times table, they end in a 0, but they're not a multiple of 20. They're not multiples of 20 because if we divided 10, 30 or 50 by 20, we would get a remainder. These numbers are not numbers that we get by counting in 20s. Now, section B can never have any numbers in it. Explain why. Well, if we look at section B, we can see that numbers here need to be multiples of 20, but can't be multiples of 10. But all multiples of 20 are also multiples of 10. If we think numbers in the 20 times table will always end in a 0 because we have 20, 40, 60, 80 and so on. But all multiples of 10 also end in a 0. If a number ends in a 0, then it will be a multiple of 10. And that's because 10 is a factor of 20. Liam thinks of a number. He multiplies the number by 5 and then subtracts 60 from the result. His answer equals the number he started with. What was the number Liam started with? So there are two ways to solve this question. One is to represent what happens with a bar model, and the other is to use trial and error. If we're using a bar model, we can show a bar to show the number that Liam thinks of or starts with. We know that he multiplies the number by 5, so we can show 5 bars to show that he's multiplied what he started with by 5. And then when he subtracts 60 from the result, his answer equals the number he started with. So if we subtract 60, then we get the same as what he started with. So we can see that these 4 bars are the same as 60. So if we divide 60 by 4, we know that each bar must be 15. So Liam started with the number 15. And we can check that it works because we can multiply 15 by 5. That gives us 75. And then when we subtract 60 from 75, we get back to 15. So back to the number that we start with. We could also use trial and improvement. So we can pick a number almost at random. So if we start with 20, we can multiply that by 5 to give us 100, and then subtract 60, so that would give us 40. But 40 isn't the same as 20, and his answer equals the number he started with. So we need to try something else. If we use 12, 12 times 5 is 60, but then his answer, so 60 minus 60, would be 0, and 0 is not the same as 12. So when we tried 20, what we got was too many, and when we tried 12, what we got was too few. So we know that we need to find or try a number between 12 and 20. So then if we tried 15, we'd find that it would work because we get 15, and that's the number we start with. In a country dance, there are 3 boys and 2 girls in every line. 42 boys take part in the dance. How many girls take part? So in each line, there are 3 boys and 2 girls, but 42 boys take part altogether. So we need to think 3 times what is 42. To figure that out, we can divide 42 by 3, and that gives us 14. So 3 times 14 is 42. So to work out how many girls take part, we can multiply 2 by the same number, and 2 times 14 is 28. So that means 28 girls take part. N and P stand for 2 numbers. N is a multiple of 5, P is a multiple of 6, and N over P is equivalent to 2/3. Find numbers that N and P stand for. So we know that N is a multiple of 5, and a multiple of 5 is a number in the 5 times table, so 5, 10, 15, and so on. P is a multiple of 6, and multiples of 6 are numbers in the 6 times table, so 6, 12, 18, and so on. But we need to choose numbers so that we can create a fraction that is equivalent to 2/3, so that simplifies to 2/3. If we have 20 as our numerator, 20 divided by 10 is 2, and 30 divided by 10 is 3. So if n is 20 and p is 30, then 20 over 30 will simplify to 2/3. We could also have n as 40 and p as 60, or n as 60 and p as 90. Put these masses in order, starting with the heaviest. So we have 800 grams, half a kilogram, which is the same as 500 grams, because 1 kilogram is 1,000 grams, and half of 1,000 is 500, and we also have 60 grams. So our heaviest mass is 1 kilogram, because that's the same as 1,000 grams. Then we have 800 grams, then half a kilogram, because that's the same as 500 grams, and then our lightest mass is 60 grams. Write the 2 missing digits in this multiplication. So we can see that both of our tens digits are missing, both of our ones digits are 9, and our answer is 2001. So what we can do here is to estimate, so to make a sensible guess as to what our tens digits could be. Now 70 times 30 is 2100, because 7 times 3 is 21, and if we have 2 end zeros in a multiplication, we'll have 2 end zeros in our answer, and 2100 is just a bit more than 2001. So our tens digits could be 6 and 2, because 69 is just a bit less than 70, 29 is just a bit less than 30, and 2001 is just a bit less than 2100. So let's use column multiplication to see if 69 times 29 gives 2001 as its answer. And we can see when we do the multiplication that it does. So our missing digits are 6 and 2, or we could change the order and write 2 here and 6 here. Circle the number that is equal to 70 thousandths. So remember, with decimals, the first digit after the decimal point is our tenths digit, then the second digit is our hundredths, and the third digit is our thousandths. But we have 70 thousandths, and we can only have one digit in each place value. So that means the 7 from 70 in our numerator needs to get pushed over into our hundredths place. Remember, with decimals, because we can only have one digit in each place value, digits get pushed over to the left. So 70 over 1,000 is written 0.070. But remember, we don't need zeros on the end of decimals. So we can ignore this end 0, and we can see that 70 thousandths is the same as 0.07, because 70 thousandths can be simplified by dividing both the numerator and denominator by 10, and when we do that, we get 7 hundredths, so that's 0.07.